So welcome to s.mathguru classes. Now today we consider some problems about maximum minimum of two variables. So if two variables given, then how to find maximum minimum. Last videos some problems is solved. Next we consider the remaining problems. The problem given show that the minimum value of u equal to xy plus a cube into 1 by x plus 1 by y is 3a square. We have to show minimum value is 3a square for the function this. Now solution is start. Here given u equal to given xy plus a cube 1 by x plus 1 by y. First we find del u del x del x xy. A cube is constant del x of 1 by x plus 1 by y. This y is constant because it differentiates partially with respect to x. This is 1 and a cube remains same. 1 by x, if we differentiate we get minus 1 by x square, and y is constant, this is 0. So we get y minus a cube by x square, we get this. So this I have written directly because we know this formula ddx of 1 by x to the power n, this is minus n by x to the power n plus 1. So we get del u del x equal to this. Again we differentiate with respect to y, del u del y. Del y of xy plus a cube del y of 1 by x plus 1 by y. This. And we differentiate partially with respect to y, then x is constant. X into 1 a cube, this is 0 minus 1 by y square. We get this. X minus a cube by y square, this one we get. We get this one for maximum or minimum. We have for maximum of minimum we have del u del x equal to 0, del u del y equal to 0. We know for maximum minimum first derivative 0, first order derivative. So del u del x is this one, y minus a cube by x square equal to 0, and this implies y equal to a cube by x square, or we can write x square y equal to a cube. This is number 1 we consider. And del u del y, we know this value x minus a cube by y square equal to 0. This implies x equal to a cube by y square. This is number we consider 2. Putting the value of x in equation number 1, we get solving 1 and 2. We get, that means we get the value of x putting in place of x here. So this will be a cube by y square whole square, this one, value of x and into y, and this equal to a cube. A to the power 6 by a to the power y to the power 4, y to the power 4 into y a cube. This is a to the power 6, this one cancel, we get y cube equal to a cube. This one taking this side, y cube equal to a to the power 6 by a cube, this equal to a cube, or we get y equal to a, y equal to we get a, and putting the value of y here, so y is, now putting the value of y here in equation number 1 implies we get x square y equal to a cube, and x square y means a, this is a cube, and x square equal to a square, x equal to plus minus root over a square equal to plus minus a. So we get x equal to a and minus a and y equal to a. Therefore, the stationary points are x is a, y is a, x is minus a, y is a. So a comma a and minus a comma a, these two are the stationary points or critical points. So we get these 2 points, and next we find the second order derivative. Next we find second order derivative. Again, del x del u del x del x y minus a cube by x square. This will be del square u del x square. This is 0, del y del x 0. A square is constant, 1 by x square minus 2 by x cube. And finally we get 2a cube by x cube. This is del u del x. Again, del x of del u del y, this one we differentiate with respect to x partially, then this will be x minus a square by y square. This is del square u del x del y, and this is 1, this is 0. So answer is 1. Again we differentiate this one with respect to y, del y del u del y del y, this one x minus a square by y square. So this will be del square u del y square 0 minus a square 1 by y square means minus 2 by y cube. So ultimately we get 2, this is a cube originally, not a square, a cube, this is a cube, a cube, a cube, this 2a cube by y cube, we get this one. Now we putting the points one by one, first a comma a, next minus a comma a. Now at minus a comma a, we have what we have, putting the point minus a comma a. First we putting here del square u del x square, this is r we consider, r equal to del square u del x square, this equal to 2a cube by x cube, x means minus a cube, this is 2a cube by minus a cube, this will be minus 2, and s equal to del square u del x del y, and this value is 1. T equal to del square u del y square. So this is putting here 2a cube by y cube. Y means a cube. This is 2 we get. Now we have RT minus s square. R is minus 2, T is 2 minus s square, minus 4 minus 1, this is minus 5, this one negative. If RT minus s square is negative, then it has no maximum minimum values. Since RT minus s square negative, therefore the function has no maximum or minimum values. Has no maximum or minimum value. It has no extreme values, extremum values. The function has no maximum or minimum values. This one. Again, putting this point at a comma a, we have r equal to del square u del x square. Del square u del x square means 2a cube by x equal to a, putting x equal to a cube, then this equal to 2, or s equal to del square u del x del y. Del square u del x del y means 1, and t equal to del square u del y square. Del square u del y square, this is the value 2a cube, and y is a cube, this is 2. Now RT minus s square, 2 into 2 minus 1 square, r means 2 and t 2 and s square means this is minus 1, 4 minus 1, this is 3. Since RT minus s square positive and r also positive, r equal to 2, this is also positive. If this is positive and r is positive, then it has minimum value. Therefore, the function is minimum at a comma a. The function is minimum at a comma a, and minimum value and the minimum value is, putting a here, this is a plus a cube 1 by a, putting x equal to a, y equal to a, we get this. This is a square a cube 2 by a, this is a square plus 2a square, this equal to 3a square. A square plus 2 is 3a square. These are proof. So show that the minimum value of u is 3a square. So we get u equal to 3a square at a comma a point. Minimum value is 3a square. This is the minimum value. This is the short. Very easy solution. Consider another problem. Examine f of x y equal to x cube plus y cube minus 3axy for maximum and minimum values. This function is given. We have to examine maximum minimum values for the given function. Here f of xy equal to x cube plus y cube minus 3axy. First we differentiate partially with respect to x on both sides. This is x cube plus y cube minus 3a xy, and x cube means 3x square. This is 0, 3ay into 1. So this will be, we get 3x square minus 3ay. This is number 1 we consider. Again we find del f del y. Del y, x cube plus y cube minus 3a xy. This is 0, this is 3y square, 3ax into 1. 3y square minus 3ax, we get. For maximum or minimum, we have, so what we have, del u del x equal to 0, del u del y equal to 0. Del u del x we get 3x square minus 3a y equal to 0, then x square equal to ay. This is number, this is 2 and this one 3 you consider. And del u del y is 3y square minus 3ax equal to 0, then y square equal to ax, number 4. So we get this one, and from this we can write y equal to x square by a. This one we consider 3, and putting the value of y here. So from solving 3 and 4, we have what we have. The value of y is x square by a, putting here x square by a whole square equal to ax. This implies x to the power 4 by a square equal to ax, and x to the power 4, this is a cube x. X to the power 4 minus a cube x equal to 0. X common, x cube minus a cube equal to 0. Then x equal to 0, x cube minus a cube equal to 0, and from this we get x equal to a. And putting the value of x equal to a in equation number 3, 3 implies y equal to x square by a. If x equal to 0, this implies y equal to 0 square by a, we get 0. If x equal to a, then y equal to a square by a, this equal to a. Therefore, the points are, one is 0, 0, another is a, a. When x 0, y also 0. When x is a, y also a. 0, 0, a, we get this. Now we have to find second order derivative. Again, del x, del f, del x. This. We differentiate this. This will be del x 3x square minus 3ay. This implies del square f del x square, This is 3 into twice x minus 0. This will be 6x. Again del x, del f, del y. Del x, del f, del y is 3y square minus 3ax. Del square f, del x, del y, 0 minus 3a. So this will be minus 3a. And the last one, del y, del f, del y. Del y, del f, del y is this one, 3y square 3ax. And this will be del square f, del y square. This is 6y minus 0, 6y. So first you consider at 0, 0, we have r equal to del square f, del x square. This is 6 into 0 equal to 0. T equal to del square f, del x, del y. This is minus thrice a. Not t, this is s. And t equal to del square f, del y square. This is 6 into 0. This will be 0. Now rt minus s square. 0 into 0 minus 3a whole square. This is 9a square. This one negative. Since rt minus s square is negative, therefore the function is neither maximum nor minimum at the point 0, 0. The function is neither maximum nor minimum at the point 0, 0. It has no maximum minimum values. So 0, 0 is over. Next, you consider another point a, a. At a, we have r equal to del square u del x square. This is 6a. This one. S equal to del square u del x del y. This is minus thrice a. This one. And t equal to del square u del t square, and this is 6y, y means a. Now rt minus s square, 6a into 6a minus 3a whole square, 36a square minus 9a square, this equal to 27a square we get. This is 27a square. This is positive we get. Since rt minus s square positive and r also positive, 6a, r also positive. Therefore, the function is minimum at what? A comma a. At a comma a, the function is minimum. We get this. And the minimum value is f of a comma a cube 3a. This is 2a cube minus 3a cube. This is equal to minus a cube. This is the minimum value. So the minimum value is minus a cube. The minimum value is minus a cube. This is our answer, and these are very easy solution, easy problem also easy, solution also easy, teacher also easy. So I hope you are all enjoying with this problem. If you are all enjoying, then please like this video. If you are new in my channel, please subscribe my channel and click the bell icon. Thank you.